Hello friends, today lecture we are to discuss new chapter, that is chapter number 3, counting principle. In this chapter we are to discuss permutation and combination formulas. All of you are familiar with permutation and combination. Permutation means arrangement and combination means selection. Okay, so we have to discuss what is meant by permutation. Permutation means arrangement. Suppose we want to arrange 10 students in a line, then in that case we have to use the permutation, and permutation formula is NPR, right? If we want to arrange R student out of N people, then we have to use the formula NPR is equal to N factorial upon N minus R factorial. This is your permutation formula. Next formula is combination. Combination means selection. If we want to select, combination means selection. If we want to select R people out of N people, if we want to select R people out of N people, then we have to use formula NCR is equal to N factorial upon N minus R factorial into R factorial. Your combination formula is equal to N factorial upon N minus R factorial into R factorial. So we have to discuss first point, basic counting, basics of counting. Basics of counting. Counting means we have to count the numbers or we have to count the sets. Okay, so we have to define cardinality of set. Let capital S be a set. Let capital S be a set if there are n distinct element. If there are n distinct elements, if there are n distinct elements in your set S, if there are n distinct elements in your set S, where if there are n distinct elements in your set S, where n is a non-negative integer, where n is non-negative integer, where n is non-negative integer, then we say that n is, then we say that n is the cardinality, then we say that n is the cardinality of set S, where small n is cardinality of set S, and we denote cardinality of set S, we denote cardinality of set S by this symbol. Cardinality of set S, that is mod S. What is mod S? Mod S means cardinality of set S. Okay, so let us take the example. Let capital A be a finite set. Let capital A be a finite set of even positive integer. Let capital S, let capital A be a finite set of even positive integers, less than 15. Let capital A be set of even positive integer less than 15. Then your set A containing, here set A is final set of even positive integer Now even integer start from 2, 4 up to less than or equal to 15. So your set is 2, 4, 6, 8, 10, 12 and 14, right? Because we have to take the number less than 15. So containing set A containing elements 2, 4, 6, 8, 10, 12, 14, that is 7 elements. So then A contain, your set A contains 7 elements. So your set A contains 7 elements. Therefore cardinality of set A equal to 7. So cardinality of set A equal to 7. Similarly, suppose we will take the second example. Let capital B be the set of, let capital B the set of positive integer. Let capital B set of positive integers less than 15, which are perfect square, What is set B? Set B is a set of positive integers less than 15 which are perfect square. Then your set B equal to, now your set B are positive integer less than 15 and which are perfect square. Now perfect square are 1, 4, 9, 16, 25, but we will take the number less than 15. Now 16 is not less than 15, so there are only 3 numbers. So therefore cardinality of B equal to 3. So cardinality of B equal to 3. Next example. Let capital S be the set of letters. Let capital S be the set of letters in the English alphabets. Then cardinality of S equal to 26, because all of you know there are 26 alphabets and your set S is set of alphabets. So cardinality of S equal to 26. Next example. The null set means empty set. The null set has no element. The null set has no element. No element means that empty set. Then cardinality of null set means empty set. Then cardinality of null set, that is empty set, is 0. Then the cardinality of empty set, that is null set, is 0. Next point we have to discuss product rule and sum rule. We have to discuss product rule and sum rule. So what is it mean by product rule and sum rule? Suppose so we will discuss product and sum rule. Suppose first we will discuss the product rule. Suppose, or if there are n1 different objects, if there are small n1 different objects, if there are small n1 different objects in the first set, comma, small n2 different object, small n2 different objects, small n2 different objects in the second set, in the second set, and if the two sets are disjoint, and if the two sets are disjoint, then if two sets are disjoint, then the number of ways to select one object, each from both the sets is n1 into n2. Okay, what is the product rule? If there are n1 different object from the first set, there are small n2 different or distinct object from second set. If two sets are disjoint, disjoint means different, then the number of we have to select one of object each from both sets is n1 into n2. This is your product rule. Okay, so we will take the example. So first example on product rule. Suppose we want to form three-letter word. Suppose we want to form three-letter word that begins and end with a vowel, and with no repeated letters, Okay, what is your question? Suppose we want to form three-letter words that begins and end with vowels and with no repeated letters. Now we know that there are 5 vowels, that is A, E, O, I, O, U, right? There are 5 vowels. Which vowels? Small a, E, I, O, U. These are your 5 vowels. Okay. Suppose we want to form 3 letters words. Okay. So this is first letter, second letter, third letter. This is your 3-letter word. Okay. So we have to form 3-letter words that begin means start and end with vowel. We want to form the letter that is start and end with vowels and with no repeated letter. In that 3-letter word there is no repeated letters. Okay. So now so there are 5 vowels, right? We know that there are 5 vowels. So your first start begins with vowels. So your first place have 5 choices. So we have 5 choices. So we have, this is first place, this is second place, this is your third place. So you have to start with vowels. So your first place has 5 choices. So 5 choices for first place, right? So 5 choices for first place, and repetition of letters is not allowed, no repeated letters, and repetition of letters is not allowed. and repetition of letters is not allowed. So we can place any one of the remaining 4 vowels. Okay, so your third place have, so out of 5 vowels, 1 vowels take in first place, so remaining 4 vowels. So your third place have 4 choices, right? Repetition is not allowed. So your 4 choices for, so remaining 4 vowels, we have 4 choices. We have 4 choices for third place, right? We have third place have 4 choices. Okay, so first place have 5 choices, third place has 4 choices, and second place, the second place with no repeated letters in that 3-letter word. Okay, so your second place have remaining 26 minus 2, that is 24 choices, right? And so we have to use 2 letters. We have to use 2 letters, right? Because first and third position we have to use 2 letters. So we have to use 2 letters out of 26 letters. We have to use 2 letters out of 26 letters. Hence we have 24 choices. Hence we have 24 choices for the second place. We have 24 choices for the second place, because your first place we have 5 vowels, it has 5 choices. For third place there is vowels but no repeated letters. That means out of 5 vowels, 1 vowel is gone, remaining 4 vowels. So your third place has 4 choices, and your second place with no repeated words, 1 letter gone for first place. Third place have also 1 letter. Out of 26, 2 letters gone, remaining 24 letters. So your second place has 24 choices. So for required number of A, so required number of ways is, so your first place has 5 choices, second place has 24 choices, and last third place has 4 choices. That is 5 into 24 into 4 equal to 480. This is your required answer. And we have to use multiplication. Multiplication means AND. In product rule, if there is AND, we have to use multiplication. In sum rule, if there is OR words, OR word means we have to use sum. So next rule we will discuss sum rule. Now we have to define what is meant by sum rule. If, so we have to define sum rule. If there are small n1 different, objects, if there are small n1 different objects in the first set, comma, small n2 different objects, in the second set, small n2 different objects in the second set, and if the two sets are disjoint, disjoint means different, that is nothing is common in that two sets. If the two sets are disjoint, then the number of ways, the number of ways, then the number of ways, then the number of ways to select an object, then the number of ways to select an object, the number of ways to select an object from one of sets, from one of the set, from one of the sets is small n1 plus n2. What is your sum rule? If there are n1 objects in the first set, small n2 objects in the second set, and if we have to select one of the objects from that two sets, and all these sets are different, so their choices is small n1 plus n2. This is sum rule. In product rule, there is n1 into n2, that is multiplication. Multiplication is product. So we will take the first example. Suppose there are 7 different French books. Suppose there are 7 different French books. Suppose there are different 7 French books, that is French language books, and 9 different English books, and 9 different English books, and we need to select one of books from this, and we need to select one book. We need to select one book from this. Okay, so how many ways we can select? So how many ways we can do it? Question mark. Okay, so what is your question? We have given 7 different French book and 9 different English books. Okay, we want to select one of book from this one. Okay, so there are all these are your different books. So first we know that when we have to use product rule, when we have to sum rule. If there all these are your difference, and we have to select the one of object, then we have to use the sum rule. And if we have to select the one object from that, if there is n, so we have to use the product rule, and we have to use the one of book. Okay, so there are 7 different French books and 9 different English books. All these are your different, so there we have to use or rule. Or means sum rule, right? So we have to select one book, right? We have to select one book, but we have to select one book out of 7 French book or 9 different English book. Okay, out of these 9 plus 7, that is 16. Out of these 16 we have to select one book. So we have to use or means that is sum rule. Sum rule means that is addition. So we have to select one book. It can be French book. It can be a French book, that is 7 choices, right? It can be French book, that is 7 choices, that is 7 different books. Or why this or? Because we can use either French book or we can select English book, or English book, or English book. So there are 9 English books, so there are 9 choices. Also all the books are different. Also all the books are different. because already we have given, that is 9 different books, English book, and 7 different French books. So all these books are different means that we have to use all these are reductions, and here or words, so we have to use sum rule. Hence by using sum rule, the total number of choices equal to, so for your French book, out of 7 we have to select 1, so there are 7 C1, that is 7 choices. Or means sum means addition. Out of 9 English book we have to select 1, or that is 9 choices. 7 plus 9, that is 16, so there are 16 total choices. Okay, if in that case we have given or means we have to use sum rule. Sum means addition, and if there is and means multiplication, we have to use product rule. So I hope all parts we have to understood. So remaining part we will study in next lecture.